Okay, I'm going to work through an example problem from section 7B just so you can kind of see what they're expecting in the homework. So what you see in front of you on the left-hand side, this is question 2 on my 7B homework. However, it's randomized in the homework, so yours might look different, but this at least gives you an idea of the setup. So in 7B, part A, they're talking about this X bar distribution. So in chapter 6, we were dealing with an X distribution, and that's when we were dealing with one individual at a time. You know, it would say find the probability that one man's height is between this number and this number, or find the probability that one woman's amount of sleep that she got per night was between this number and this number. Okay, so we were looking at the probability of one individual. In chapter 7, we are looking at samples, more than one. So for example, for this problem, we have 49 individuals in a group, okay? How does that make a difference? Well, in general, if you have one individual, then you are dealing with an X distribution. And if it's normal, it's going to have a certain mu and a certain sigma that's given in the problem. Okay, it's going to be flat out given. However, if you have a group of individuals, then you are going to be looking at that average of the group, so an X bar, and if that's normal, it's going to have the mu that's given, but the standard deviation is going to be sigma over the square root of n. Okay, so instead of just giving the standard deviation in the original problem, like they would with one individual, for a group of individuals, you have to calculate this new standard deviation right here. Okay, and that's what they're asking for in this problem in part A. So let me move this down. So in 7B, number 2, part A, they are saying what is the distribution of X bar? So X bar is approximately normal, and we're going to talk in a second about how we know this is normal, with the average that is given, which is 195, that's just given in the problem, and then not just the regular standard deviation of 7.3 that's given, but instead you're going to take that 7.3 and you're going to divide it by the square root of what the sample size is, in this case 49. So to clean that up a little bit, it would be 7.3 divided by 7. Okay, and you would go ahead and figure out that decimal, which they're asking you to round that to 4 decimal places, which in this case, I'm getting, when I did 7.3 divided by 7, I have approximately 1.0429. Okay, so when you have a group of data, that standard deviation is going to be slightly different. Now, how did we know this was a normal distribution? Well, in chapter 7, we talk about the central limit theorem, and basically, if you're dealing with a sample and finding the average of that sample, then you know it's normal if the sample size is more than 30. So in this problem, since the sample size is 49, it automatically becomes normal, even if they didn't flat out just tell us it was normal. So that's how we know this one's normal. B, for the group of 49, find the probability that the average hand length is more than 197. Draw a picture. Okay, that's my biggest hint that I can tell you. Draw a picture of every single one of these. So we have a normal curve for the reasons stated earlier. The average is 195, so I put that in the middle, and I want to find the probability of being more than 197. So there's my 197. More than 197 is going to be to the right. You're going to shade as it gets bigger. If you ever want to find area under the curve, the most direct way of doing this is using our normal CDF on the calculator. And normal CDF, you tell it 4 numbers. Lower number of your shading upper number of the shading, and then mu and sigma. So 197 is the lower end of my shading. The upper end of my shading really continues forever. So really what you should pick is a really, really, really large number. I'm going to pick 1E99. And to get that E, it means scientific notation. That means 1 times 10 to the 99th power. That E on the calculator is right above the comma button, and it shows up as a double E, E, capital E, capital E. But when you actually push it, it just shows up once like I've written above. And the mu is 195 as given, and the standard deviation, let me shift this over a little bit. The standard deviation is that new one that we calculated, since we're dealing with a group of data, not just one. Okay, when you input that into the calculator, the normal CDF is under the second distribution button, and you type in those 4 values. And I am coming up with approximately 0.0276. 0.0276. Okay, so that is part B. And then part C. Find the third quartile for the average adult male length for this, male hand length for this sample size. So third quartile, we're talking about the 75th percentile. I know 195 is my average, and I want to find this number such that we're looking at a 75th percentile. Give me a second while I'm trying to get that rectangle to go away there. Okay, sorry, that's not going away there. So if we're looking for a 75th percentile, if 195 is in the middle, we are looking for this number right here. I'm going to put a question mark. And we want that number such that this is 0.75 of our area under the curve. So when you want to find a data value given a probability, like in this problem, you're going to be using something called the inverse norm. The inverse norm, you have to tell it 3 values, area to the left of the guy that you're looking for, and then mu and sigma. So the area to the left of the guy that we're looking for is 0.75. That's what my picture shows. My mu is 195 as given, and my standard deviation is that 1.0429. Sorry, that kind of got squeezed in there. Inverse norm is found in the same location that the normal CDF is. It's under second distribution. Again, you tell it these 3 values. And I am coming up with approximately, and we're going to go 4 decimal places here, 195.7034. I'm going to double check that they want 4 decimal places, and they do. Okay, so those are the 2 things you're going to be using in this chapter. Okay, you're going to be using the normal CDF and the inverse norm. The only thing different from chapter 6 again is that if you're dealing with a group of data, you have to use the standard deviation divided by the square root of n. All right, good luck.